Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on linear algebra, chapter linear equations, lecture number 6, in which I will solve some more problems on linear non-homogeneous equations involving parameters lambda, mu or eta. Now we solve the problem number 2. The problem is, for what values of the parameter lambda the following equations fail to have unique solution. These are three equations. Here lambda, here we see lambda. Next question is, will the equations have any solutions for these values of lambda? Now we solve this. Here we have three equations with three unknowns x, y and z. The coefficient matrix A is A equal to, here coefficient 3 minus 1 lambda 2 1 1, here 1 2 minus lambda, this is 3 by 3 matrix, implies that determinant of A equal to, firstly we take 3 multiply, here 1 multiply minus lambda minus 2, here minus 1, 2 multiply minus lambda minus 2 lambda minus 1 multiply 1 plus, here lambda, here 2 multiply 2 4 minus 1 multiply 1 4 minus 1, this is equal to minus 3 lambda minus 6, here minus plus minus 2 lambda, here minus 1 plus 3 lambda, this is equal to minus 3 lambda plus 3 lambda cancel, here minus 2 lambda minus 7, this is number 1, this is number 2. Since number of unknowns equal to 3, therefore if rank of A equal to 3, then we may get unique solution. For this, determinant A not equal to 0 implies that minus 2 lambda minus 7 not equal to 0 implies that minus 2 lambda not equal to 7 implies that lambda not equal to minus 7 by 2. Therefore, unique solution exists if lambda not equal to minus 7 by 2. This is answer of first part. When lambda equal to minus 7 by 2, then A equal to, here matrix 3, 2, 1, minus 1, minus 7 by 2, here 1, here 1, here 2, here 7 by 2. This is the coefficient matrix. This is number 3, this is number 4. Therefore, augmented matrix AB will be, firstly we write coefficient matrix three, 2, 1, minus 1, 1, 2, minus 7 by 2, 1, 7 by 2, colon, colon, colon. Here 1, 2, minus 1. This is right side of the equation. 1, 2, minus 1. This is 3 by 4 matrix. This is number 5. Now, we try to make augmented matrix AB to echelon form. We apply. Now we try to put here 1. So we mutually exchange R1 and R3, row 1 and row 3. We get equivalent matrix. Here 1, 2, 1, 2, 7 by 2. Here minus 1. Here 2, 1, 1, 2. Here 3, minus 1, minus 7 by 2, 1. Now we try to make here 0 and also here 0 by applying in place of row 2 minus 2 row 1, and in place of row 3 minus 3 row 1. We perform row 2 in place of row 2 minus 2 R1, row 1, 2 minus 2 multiply 1 means 0, 2 minus 2. Here 1 minus 2 multiply 2 means 1 minus 4, this is minus 3. Here 1 minus 2 multiply 7 means minus 6. Here 2 minus minus 1 multiply 2, that is 4. Here 4 in this place. R3 row 3 minus 3 into row 1. 3 minus 3 into 1 means 0. Minus 1 minus 3 into 2. Here 6 minus 6 minus 1 minus 7. Here minus 7 by 2 minus 3 into 7 by 2, that is minus 14. Here 1 minus 3 into minus 1 means here 3 into minus 1 minus 3 minus minus 3 means plus 3. 1 plus 3 4. Now here we want to make 0. So we apply in place of R3 row 3. Row 3 minus 7 by 3 multiply row 2 and minus 7 minus 7 by 3 multiply minus 3 means plus 7. Minus 7 plus 7 0. Here in place of R3 minus 14 minus 6 multiply 7 by 3. 3 2s are 6. So here remains 2 and 7 2s are 14. So minus 14 plus 14 0. In place of this 4 minus 7 by 3 multiply 4, we get minus 16 by 3. Let this is number 6. Here we see that the coefficient matrix has two non-zero rows, this row and this row. This part is coefficient matrix, this part. Two non-zero rows, but the augmented matrix has three non-zero rows. Therefore, rank of coefficient matrix equal to 2 and rank of augmented matrix AB equal to 3. Therefore, rank of coefficient matrix not equal to rank of augmented matrix. Hence, the system of equations is inconsistent. That means we cannot get the solution for lambda equal to minus 7 by 2. So our problem is solved. Now we solve the next problem. Next problem is for what values of eta the equations x plus y plus z equal to 1, x plus 2y plus 4z equal to eta, x plus 4y plus 10z equal to eta square have a solution and solve them completely in each case. Now we solve this. Since we have three equations in which we have three unknowns x, y and z. The coefficient matrix A is A equal to, here coefficient 1, 1, 1, 1, 1, 1, here 1, 2, 4, 1, 2, 4, here 1, 4, 10, 1, 4, 10. This is 3 by 3 matrix. This is number 1. Implies that determinant of A. Here we write 1, here 2 multiply 10, 20 minus 4 multiply 4, 16. Here we take minus 1, minus 1, here 1 multiply 10, 10 minus 1 multiply 4, 4 plus 1, here 1 multiply 4, 4 minus 2 multiply 1, 2. This will be here 20 minus 16, 4, here 10 minus 4, 6, minus 6, here 4 minus 2, 2, and this is 0. Therefore, determinant of A equal to 0 implies that A is singular. Therefore, unique solution is not possible. We may get no solution or infinite number of solution. The augmented matrix AB is augmented matrix AB equal to, firstly we write the coefficient matrix 1, 1, 1, 1, 2, 4, 1, 4, 10. Here right side is 1 eta square. This is number 2. Now we transform augmented matrix into echelon form. For this, firstly we apply. Here we have to make 0, here we have to make 0. Means in place of R2, row 2 minus row 1, and in place of row 3 minus row 1, we get equivalent augmented matrix. Here 1, 0, 0, here 1, 1, 1, here 2 minus 1, 1, here 4 minus 1, 3, here eta minus 1, here 4 minus 1, 3, here 10 minus 1, 9, here eta square minus 1. Now here we have to make 0. So by applying, in place of R3 minus 3R2, we get equivalent augmented matrix. Here we write first row same 1 1 1 1, second row same 0 1 3 eta minus 1. In place of third row 0 minus 3 into 0 0, 3 minus 3 into 1 0, here 9 minus 3 into 3 0, here eta square minus 1 minus 3 into eta minus 1. This is equal to 1 1 1 1 0 1 3 0 0 0. Here eta minus 1, here eta square minus 3 eta, here minus 3 multiply minus 1 3, here minus 1 2. Let this is number 3. Since rank of coefficient matrix, rank of A equal to 2, here number of non-zero rows, and for getting solution rank of coefficient matrix equal to rank of augmented matrix. It is necessary that rank of augmented matrix must be 2 for getting solution. So here we have to make 0. For this eta square minus 3 eta plus 2 equal to 0 implies that eta square minus 2 eta minus eta plus 2 equal to 0 implies that eta common, eta minus 2 minus 1 eta minus 2 equal to 0 implies that eta minus 2 multiply eta minus 1 equal to 0 implies that eta equal to 2 and 1. This is number 4. Putting eta equal to 2 in theory, we get equivalent augmented matrix 1 1 1 1 0 1 3 eta equal to 2 2 minus 1 means 1 0 0 0 and this is 0. Therefore corresponding equations are here 1 1 1 0 1 3 0 0 0. This is equivalent coefficient matrix. X y z unknowns and right side is 1 1 0 implies that we multiply two matrices and we get x plus y plus z equal to 1 and y plus 3z equal to 1. Let This is number 5. This is number 6. From 6 we get y equal to 1 minus 3z. Putting z equal to t. Arbitrary number. Y equal to 1 minus 3t. This is number 7. Using 7 in 5, x equal to 1 minus y plus z. This is equal to 1 minus y is 1 minus 3t and z is t. This is equal to 1 minus 1, 3t plus t, 2t. This is 2t. Therefore, for eta equal to 2, we get solutions. X equal to 2t, y equal to 1 minus 3t, and z equal to t, where t is arbitrary number. This is number 7. When eta equal to 1, we get equivalent augmented matrix. AB is equivalent to here 1, 1, 1, here 1, here 0, 1, 3, here eta minus 1, eta is 1, 1 minus 1, 0, here 0, 0, 0, 0. Therefore, corresponding equations will be here 1, 1, 1, 0, 1, 3, 0, 0, 0, coefficient matrix, unknowns x, y, z, and right side is 1, 0, 0, implies that here x plus y plus z equal to 1, here y plus 3z equal to 0. This is number 8, this is number 9. From 9, y equal to minus 3z equal to minus 3, in place of z we write t, putting z equal to t, arbitrary number. This is number 10. Using 10 in 8, we get x equal to 1 minus y plus z equal to 1 minus y is minus 3t and z is t. This is 1 minus minus plus 2t. Therefore, solution B, x equal to 1 plus 2t, y equal to minus 3t, and z equal to t. for eta equal to 1. So our problem is solved. We have seen that coefficient matrix is singular. So we do not get any unique solution. And after getting eta equal to 2 and eta equal to 1, we get infinite number of solutions. For the case of eta equal to 2, we get that x equal to 2t, y equal to 1 minus 3t and z equal to t, where t be arbitrary number. This is arbitrary, so we get infinite number of solutions. And for eta equal to 1, we get x equal to 1 plus 2t, y equal to minus 3t and z equal to t. T is arbitrary. Here also we get infinite number of solutions. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.